Welcome to our interactive notes, lesson 2, part 1. So our lesson 2 is our prime number sieve, and that's going to be on pages 7 and 8. So we turn over to page 7. And then part 2 will be on page 8. So our prime number sieve. Our content objective, 4th grade, OA's Operations Algebraic Thinking, B4. I can determine whether a given whole number up to 100 is a prime or composite number. Language objective. I can use divisibility rules to find factors and definitions to explain why a number is prime or composite. Social objective. I can work with others to create models to prove numbers are prime or composite. Okay, here we have 2 vocabulary words. We have prime number. A prime number is a positive counting number. So that means counting numbers, when you start counting with 1. We also call those natural numbers. So 1, 2, 3, 4, 5. Those are what we call counting numbers all the way up. With exactly 2 factors, 1 and itself. No other ones, just those 2. Composite number. A composite number is a positive counting number with more than 2 factors. So no negative numbers will be a part of this, and no decimals or fractions. It's going to be positive counting or counting or natural numbers with these. So exactly 2 factors, more than 2 factors. So this is going to be our actual sieve. Now what a sieve is, if you remember ever playing in the sand, maybe in kindergarten, and you had that tray that had holes all the way through them, and you put the sand in there and you shake it and you're left with little rocks in it. Well, that's the idea of what we're doing here. We're going to shake out our composite numbers and leave just the prime numbers behind. So first we're going to cross out 1, because 1 has only 1 factor. You can only multiply 1 times 1 to get 1. That's the only counting number that you can use. So that's 1 factor. That doesn't meet either definition, so we cross that one out. Then we get to 2. 2 is our very first prime number. The only 2 factors are 1 times 2 and 2 times 1. That's the only factors we have. So 2 is our very first prime number and our only even prime number. So we circle that, and now we cross out all its multiples, because after that anything that you can multiply to 2 now has more than 2 factors. So I can cross out all other even numbers. So we're going to go through right now, and I'm going to cross out 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54. So if you see a number that's an even number and it's not the number 2, you already know that it's composite. Because every other even number has 2 as a factor, so that makes it more than 2 factors and composite. So we're just crossing out all those even numbers. 82, 84, 86, 88, now that doesn't mean that all odd numbers are prime. You'll see that in a little bit. But every other prime number other than 2 is an odd number. 108, 110. Now our standard says all the way up to 100, but we go up to 180 so that we can use this tool with our daily fraction and our 180 school days. So for our standard, we could stop here at 100, and all the prime and composite numbers would be fine there. But we want a tool that's useful for other things as well, which is our daily fraction. Okay. 146, 148, 150, 152, 154, 156, 158, 160, 162, 164, 166, 168, 170, 172, 174, 176, 178, 180. All right, we just shook out our first set of composite numbers. All these that are crossed out, other than 1, are composite. So we just shook out all the 2's, all the multiples of 2. So we've narrowed it down to the rest of our prime numbers. Now this prime number sieve is actually pretty ancient. There's a Greek name, Erathion. I forget exactly how to say it. But this is his prime number sieve. So this is a strategy that's about 2,000 years old of a way to find prime numbers. So next prime number is 3. The only 2 factors are 1 times 3. No other numbers multiply to make 3. So now we're going to cross out all multiples of 3. Now some are already done, so we got to make sure we're being careful. So 3, 1, 2, 3, 6, already done. 1, 2, 3, 9. 9 is composite. It's actually a perfect square. 1, 2, 3, 12 is already done. 1, 2, 3, 15. 1, 2, 3, 18. 1, 2, 3, 21. We cross up. 1, 2, 3, 24. 1, 2, 3, 27. 1, 2, 3, 30. 1, 2, 3, 33. 1, 2, 3, 36. 1, 2, 3, 39. 1, 2, 3, 42. 1, 2, 3, 45. 1, 2, 3, 48. 1, 2, 3, 51. 51's a tricky one. Sometimes people see that and think it is a prime number, but it's not. It's a multiple of 3, so it has more than 2 factors. 1, 2, 3, 54. 1, 2, 3, 57's another one like that, that people think it's prime when it's not. 1, 2, 3, 60. 1, 2, 3, 63. 1, 2, 3, 66. 1, 2, 3, 69. We cross out. 1, 2, 3, 72. 1, 2, 3, 75. 1, 2, 3, 78. I counted 4. 1, 2, 3, 81. 1, 2, 3, 84. 1, 2, 3, 87. We cross out. 1, 2, 3, 90. 1, 2, 3, 93. 1, 2, 3, 96. 1, 2, 3, 99. 1, 2, 3, 102. 1, 2, 3, 105. 1, 2, 3, 108. 1, 2, 3, 101. 1, 2, 3, 104. 1, 2, 3, 117. 1, 2, 3, 120. 1, 2, 3, 123. 1, 2, 3, 126. 1, 2, 3, 129. 1, 2, 3, 132. 1, 2, 3, 135. 1, 2, 3, 138. 1, 2, 3, 141. 1, 2, 3, 144. 1, 2, 3, 147. 1, 2, 3, 150. 1, 2, 3, 153. 1, 2, 3, 156. 1, 2, 3, 159. 1, 2, 3, 59. 1, 2, 3, 162. 1, 2, 3, 165. 1, 2, 3, 168. 1, 2, 3, 171. 1, 2, 3, 174. 1, 2, 3, 177. 1, 2, 3, 180. We kind of have a pattern going on here. We get 2, 2, 2, 2, 2, 2. But we've shaken out all the multiples of 3. Now we're going to do our next prime number, which is 5. It has only 2 factors, one in the number itself. 5s are easy because it either ends in a 0 or a 5. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 110, 115, 120, 125, 130, 135, 140, 145, 150, 155, 160, 165, 170, 175, 180. So basically we just crossed out everything under the 5. All these should be crossed out because these are all multiples of 5. They all end in a 5, so they can be divided by 5. Okay, so we've shaken out the multiples of 5. We've got 3 prime numbers so far. Next prime number is 7. So we're going to count by 7s, find all our multiples. 1, 2, 3, 4, 5, 6, 7. We get 14. 1, 2, 3, 4, 5, 6, 7, 21. A lot of these are already going to be crossed out. 1, 2, 3, 4, 5, 6, 7, 28. 1, 2, 3, 4, 5, 6, 7, 35. 1, 2, 3, 4, 5, 6, 7, 42. 1, 2, 3, 4, 5, 6, 7. Finally one to cross out, 49. That is a multiple of 7. 7 times 7, it's a perfect square. 1, 2, 3, 4, 5, 6, 7, 56. 1, 2, 3, 4, 5, 6, 7, 63. 1, 2, 3, 4, 5, 6, 7, 70. 1, 2, 3, 4, 5, 6, 7, 77. Another one we can cross out. 1, 2, 3, 4, 5, 6, 7, 84. 1, 2, 3, 4, 5, 6, 7, 91. 1, 2, 3, 4, 5, 6, 7, 98. 1, 2, 3, 4, 5, 6, 7, 105. 1, 2, 3, 4, 5, 6, 7, 112. 1, 2, 3, 4, 5, 6, 7, 119. Another one to cross out. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So what we're doing here, these, every time I count 7, that's actually a multiple of 7. So we know that these are composite. 1, 2, 3, 4, 5, 6, 7. We get to 140. 1, 2, 3, 4, 5, 6, 7, 147. 1, 2, 3, 4, 5, 6, 7, 154. 1, 2, 3, 4, 5, 6, 7. Another one we can finally cross out. 161. 1, 2, 3, 4, 5, 6, 7, 168. 1, 2, 3, 4, 5, 6, 7, 175. 1, 2, 3, 4, 5. So we are done with our 7s. Okay, we're getting it narrowed down. Next one is 11. So our multiples of 11, well, let's see, 11, 22, 33, 44, 55, 66, 77, 88, 99, 110. And we get to finally 110 plus 10 is 120 plus 1 more is 121. This is a perfect square. This is 11 times 11. Then we get down that diagonal. 11 more is 132. Then 143. That is 11 times 13. 154. 165, 176. So we got our 11s done. Okay, let's look at our 13s. So we have 13. Then next we have, when we add 10, 23 plus 1, 2, 3, 26. Add 10, 1, 2, 3, 39. Add 10, 1, 2, 3, 52. Add 10, 1, 2, 3, 65. Add 10, 1, 2, 3, 78. Add 10, 1, 2, 3, 91. Add 10, 1, 2, 3, 104. Add 10, 1, 2, 3, 117. Add 10, 1, 2, 3, 130. Add 10, 1, 2, 3, 143. Add 10, 1, 2, 3, 156. Add 10, 1, 2, 3. Finally, we have one to cross out. This is actually 13 times 13, 169. It's a perfect square. Then we get add 10 and 1. So we're done. So we done our 13s. And then we just have to check for 17. That's our next prime number. If we can't find one to cross out for 17, then we're actually done with our sieve and we found all our prime numbers. But let's check. So we're going to add 10 and then 1, 2, 3, 4, 5, 6, 7. 134. We add 10. 1, 2, 3, 4, 5, 6, 7. 151. Add 10. 1, 2, 3, 4, 5, 6, 7. 68. Add 10. 1, 2, 3, 4, 5, 6, 7. 85. So I'm doing kind of a break apart as I'm doing this because I'm adding the 10 from 17 first by moving down, and then I'm adding the ones. 1, 2, 3, 4, 5, 6, 7. 102. Add 10. 1, 2, 3, 4, 5, 6, 7. 119. Add 10. 1, 2, 3, 4, 5, 6, 7. 136. Add 10. 1, 2, 3, 4, 5, 6, 7. 153. Add 10. 1, 2, 3, 4, 5, 6, 7. 170. And then we can only add 10. We had none to cross out, so we're done with our sieve. That means every number that's left over is a prime number. So we're going to go ahead and circle. So you should be circling. You should have 2, 3, 5, 7, 11, 13, 17 already circled. Now we're going to circle 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 101, 103, oh, I forgot 97, don't forget 97, 107, 109, 113, 127, 137, 131, sorry, I missed that one, 139, 149, 151, 157, 163, 167, 173, and then 179. Now there have been people who've studied their whole lives to see if there was a pattern in how prime numbers are formed, and so far they have not found them. But these are prime numbers. They're used in a lot of different ways, and so now we're going to do our 3-column notes in part 2.